What's going on, everyone? My name is Johnny Bannon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to go over another important IP service, the Simple Network Management Protocol. Now, this is a, kind of like the name implies, it is a simple network management protocol, but it can get pretty deep in how it can monitor your networks, and especially working with all the different SNMP servers that are available out there in the market. Now, when we jump into this, we're going to go over network management and a little bit of the history in general, right? Because when I first started in this career field, in networking specifically, and in Cisco networking, working with Cisco iOS, SNMP was kind of the only solution for network monitoring as far as actual network infrastructure devices go, as kind of a centralized view. And back then, back in 2012, 13, 14, when I first started, SNMP servers could do some configuration, could give you some consistency. But now in the past, I would say 4 to 6 years, the trends of network management and monitoring have kind of gone to a more automated and software controlled system rather than just a management protocol like SNMP. And look at that. I can see it on my screen right there that this is already spelled incorrectly. So let me fix that. Whew. There we go. This is gonna be an official recording, so don't take everything I said as not right just because I'm spelling this spelling. But as I was saying, so nowadays SNMP still is used a lot in the enterprise, but now we've kind of gone over to APIs. Cisco has SD access, SD-WAN, where you kind of really don't need an SNMP server now if you're in a completely not a vendor neutral environment. If you're just using Cisco. There's NetConf and RESTConf. There's northbound and southbound APIs, which now can control and monitor your network in a similar way SNMP did, but a lot better. But on the CCNA exam, we have to learn about SNMP. It is a good skill to still know. It's still used broadly. And even though it says simple, it ain't so simple sometimes. It can get pretty complex. And really the complexity comes with when you want to have a feature-rich environment using SNMP, meaning you want multiple sensors and you want your SNMP manager or server to do a lot of different things other than just maybe monitor uptime and availability via a ping test. So we're going to kind of get into that when we get into the lab to kind of show you just SNMP is a skill in itself to learn to make you a little bit marketable. Like on my resume, I don't put SNMP, I put SolarWinds. And that's because configuring the iOS to connect to an SNMP server, kind of the easy part. You should have a simple baseline in your network saying, here's the SNMP credentials we use or the community strings. What gets difficult is setting up that server to do everything we want to give us that single pane of glass, which again is now transitioning to other network management protocols. So let me just actually jump right into it, right, instead of talking about it. So let's go over our agenda. So we're going to go over some network management overview, kind of what I've been talking about, just network management holistically, not just as it relates to SNMP. And then we're going to jump into the SNMP architecture and components. Then we're going to go over the MIB, a very important thing to understand. And then we're going to go over the different SNMP message types. So the GET messages, what the difference between traps and informs are. And then we're going to get into the SNMP versions because there's been a lot of versions since SNMP was first released. Version 3 is going to be the one and 2 are going to be the ones we go over as far as configuration goes in our lab. And then we're going to get into SNMP configuration and verification. So before we start, let me go over the CCNA exam objectives. You can kind of see here what I was already kind of doing prior to this. We want the PDF. So I kind of just want to show you what all the CCNA wants you to do is explain the function of SNMP and network operations. So if we were just trusting Cisco and that it's going to be that simple on the test, this slide could be, or this lesson could be probably less than 5 to 10, somewhere between 5 to 10 minutes. SNMP is a way to monitor and manage devices in a network. Boom, done. We could go over the UDP port, the versions, and we'd be good. But probably knowing Cisco, there might put a little bit of, stump the chump questions in there by SNMP. So I hope to keep this lesson at least under an hour, but we may go a little bit longer if you're including the time for the lab. All right, you can see I love using Canva. Let's get back to our agenda. Awesome. So now let's go over some network management overview. So whether or not we're using some SDN or DNA Center, NetConf, RetsConf, or NetFlow, network management all is under one principle. Really, that's giving us that single pane of glass for all of our devices on our infrastructure. So no matter what network management server or service we're using, the goal is kind of all the same. Giving us the ability to just look at our network holistically, and now maybe the abilities to make changes and create consistent baselines. Well, if SNMP, originally it wasn't meant for that. It was meant just to collect data on your devices so you can monitor and maybe set up alerts. And then with version 3 and some other additional features, we did get the ability to actually write config changes via SNMP. But it still wasn't that nice flow, that fabric-centric network that SDN could provide. So nowadays, in my opinion, SNMP really is just to get yourself maybe a network map. But now we're using different things like DNA Center, SDN applications, or you're automating using NetConf and RetsConf to pull data as well as make changes. And there's other automation stuff that will not important for this section, but does kind of flow into that network management overview. So if I was giving this class 4 or 5 years ago, we probably wouldn't even be talking about this in an SNMP section. But I think it's important to note that network management, there are a lot of options now rather than just an SNMP server. So now let's jump into the actual SNMP components. So the first component we're going to talk about is an NMS, which stands for the Network Management Server. So the Network Management Server, or the SNMP Manager, so those names are similar, okay, or they're synonymous. That is the software that's going to run on a dedicated server, or maybe a container now, or even in the cloud. It's in a cloud instance, which still could be a dedicated server, that's going to monitor all of our SNMP agents or our network devices. So an NMS, or the SNMP Manager, is the device that's going to pull network devices for the information. So this SNMP server, network management system, and here I have the SolarWinds symbol, is going to be sending out SNMP messages or polling all these network devices for the information that it wants. And we usually call those like sensors. So we could build like a uptime sensor in our NMS system. And it's going to go out and pull that information. So even though this is called the SNMP Manager, the server, the network management server, typically in a client-server architecture, our client is the one reaching out for information on the SNMP server. But in this environment, it's actually kind of opposite, where this server is reaching out to all of our clients or SNMP agents asking for information about them. So it's still a server. It's still considered a server because it's going to host all the information that it pulls, but kind of like that little fundamental change that even though this could be considered a client-server architecture, it's actually not the client sending information. It's the server polling. Now, for any of you guys out there that watching this video say, that's not true, we could have SNMP agents send information. Correct. We can have traps and informs set up that alert the server of something that we configured to alert the server. Meaning if something comes down, we could have configured an SNMP trap or inform message to say, hey, tell that server about this. But in just the basic level at SNMP, that's wasn't included. That's what came on after as we made improvements. So when describing the architecture, let me get some of this stuff out of the way. When describing the architecture of SNMP, that's how we describe it, right? That server is the one that reaches out to the SNMP agents or clients. And then the SNMP Manager is typically going to be configured through a GUI, And there's so many different flavors, versions, and brands of NMS software, SNMP servers or managers. I mean, it's really abundant. Even during this building this slide deck and building this lesson, I've used SolarWinds in my enterprises because I work in the government and they love SolarWinds. But I was like, I'm not going to pay for SolarWinds and I don't want to use the free service. I want to try something new. And I actually went through 3 different SNMP managers that I'll talk about in the labs. One called Zabbix, Datadog, and then PRTG. And honestly, for this, I was like, what's the simplest? And I used PRTG in the lab environment because I just wanted to show you guys what it looked like. But SNMP managers, from far as I can tell, is really not that simple. I mean, again, it's a skill in itself to be able to go through their GUIs and put the sensors you want, and then being able to automate some of the process. So I'm glad that's not testable because that can be pretty in-depth too to learn a whole SNMP manager product. Okay, now moving on to another component, the SNMP agent. So SNMP agents are the devices that are being managed by the SNMP server or the NMS system. So an SNMP agent will need to have the SNMP software or agent software installed and operational to actually respond to the NMS's SNMP request. So essentially what that means is when we have this NMS server, not every device is just ready to respond to SNMP messages. They need to know how to speak the SNMP language. They need to have the SNMP agent software installed. Now for Cisco iOS, it comes with it already. We just had to activate it via the CLI. But like for your regular desktop environments, like an Ubuntu desktop, it doesn't just come with SNMP automatically installed. We may have to even install custom agent software depending on the NMS server we're using. So really just depends. In our environment and our Cisco infrastructure, SNMP is going to be there. And then every SNMP agent will have to have a MIB on it, which usually comes with the SNMP software. And a MIB stands for a Management Information Base. What that Management Information Base is a standard database that has object identifiers that describe certain interfaces and technologies used on a system. So we're going to get into the management information base in the next slide to show you what that is and what we're talking about. But essentially, every SNMP agent is going to reference their MIB when they get an SNMP request from the NMS server. So essentially, when that NMS sends a SNMP request or GET request, it's going to say, hey, I want to learn about this interface. And it's going to send in there an object identifier, and the SNMP agent is going to look into its MIB and say, do I have that object identifier for this interface? Yes, I do. Now let me respond back to my NMS server. And I think I have a slide where I'm supposed to go over that, so let me not jump ahead. And yes, right here. So the way this fully SNMP architecture works is, again, we're going to have our network management server or SNMP manager. And then we're going to have our SNMP manager software. In this case, we're using SolarWinds as a symbol there in our example. And they're going to send an SNMP GET request message. So I have a GET there, but it's going to be a GET request message. When this SNMP agent receives it, if it's configured and connected to the NMS, meaning it's part of the same community string or an SNMP version 3, we're authenticating to it. Essentially, we've set up this SNMP agent to respond to SNMP messages from this server. What it's going to do is look into that GET request, and in that GET request, there's going to be something that says, hey, I want to pull your interface delay. Just as an example. And that interface delay is going to have an object identifier that this NMS pulled from its MIB or from a MIB database. And it's going to be something, a list of numbers. Just as an example, right? And that's a hierarchical system. So this one maybe stands for like network, and then this two stands for like interface. And this none of this is accurate, just showing you. We're going to get into it. So it's going to look into its MIB database and say, okay, I do know how to respond to this. Let me send back a GET response to my NMS saying, hey, yes, I do know what you're talking about. Here's the OID for my interface. Make sure we're matching up. And now you can pull that interface and get information from me. So that's kind of how it works, right? We start at the NMS server. We configure a sensor or something to be pulled. We send our SNMP GET messages to the agent that we're trying to pull. That agent references its database to make sure that it can respond with the correct information. And then it sends an SNMP GET response back. And we're going to go over what these messages mean as well. Okay, now let's get into the actual MIB. So the MIB is the database of variables or objects that are used to define information about that SNMP agent. So the MIB database is going to store this information in a hierarchical fashion, meaning that essentially this one would be the root of that database, and this is going to stand for something broad like, I don't know, maybe International Standards Organization, and then the 4 stands for maybe Cisco, and the 6 stands for like interface, and the 7 stands for like traffic analysis, and the 9 stands for delay, right? So kind of building on top of each other. And in every SNMP agent, we're going to have that full MIB database to reference. So let's go over what that looks like. So here's that SNMP MIB structure. So as you can see here, it's hierarchical. So we start out with ISO, and then the organization, and then DoD, and then internet. And then from there, we come over here to directory, MIB2, and then interfaces. So this is just an example of everything that can be pulled in a hierarchical structure. So what this is trying to say is that if you have an ISO MIB, meaning you're able to view the entire structure or folder of ISO, that means you have access to pretty much every OID in existence, or every OID that's under this ISO MIB. Now, let's say you just wanted to pull information based off MIB2. Well, think of this as just like folders, essentially. Kind of like when we go through the directories of a Linux host, we start at the root, then we go into like Etsy, and then in there, Etsy has a bunch of directories we may need to reference. It's kind of the same thing. Think of it as just a folder structure, where if I'm able to access ISO and pull information from ISO, that means I can pretty much pull anything in that MIB. But let's say I just want my SNMP agent to only get pulled for information that's a part of MIB2, then I can configure that. It's actually with a command called SNMP server view, and then like the name of where you want it to view in the MIB structure. And I could type in MIB-2 and be like, okay, that means we can only pull for stuff that falls under here. So if I say, hey, SNMP agent, you're only allowed to get pulled for stuff under MIB2, that means none of this can be pulled now. So typically that command, if we want to give some access control to what OIDs we'll be able to respond to or reference when we get a request from our NMS, if we just put ISO, right? We want to see everything, the root of this MIB structure. I hope that makes sense. And that used to confuse me when I first started learning. But essentially, yeah, if you just think of it as like a folder structure. So like if I go to File Explorer here, and I go to the C drive. So the C drive would essentially be this one ISO here, because it contains everything. The C drive contains my entire computer system. And then let's say I only want, let's say this was an SNMP, I only want my user folder to be accessed. I could reference that in SNMP and say, hey, I don't want to give that NMS server access or pull information for everything in the C drive. I just want them to pull for information that exists in this folder, John B. Okay? So that's kind of a way I kind of learned the SNMP nib structure. It's really just a directory if you think about it. Okay, now let's get into the SNMP message types. So we're going to go over the message type get. So the SNMP message type get, it's how we get all of our information, for our NMS server from our agent. So the get request, this is going to be coming from our network management server. It's going to ask the SNMP agent to report a value back to the NMS. So I need info on OID, whatever, right? It's going to send back a get response, an SNMP get response with the information for that OID, if it can. And then we have an SNMP get next request, which is going to request a list of instances from our SNMP agent. So essentially what that's going to say is, hey, I want to learn about OID 1.4.6.8.9, but I also want the next variable in that tree structure. So essentially that get next request is saying, keep getting me the next thing in that tree structure until it stops. So pretty much give me everything in this directory 9 here. And then we have an SNMP get bulk request, which this is going to allow you to get values for all the mid variables in a particular branch. So what that means is if I want to get a bunch of different information, I can ask for like this whole folder here through this whole directory here. It's kind of in the name. It's a bulk request saying, hey, I want to learn about everything in this OID folder directory or structure. And then the SNMP messages you'd get back from this would be a get bulk response. So from the agent, you would send back a get bulk response. All right. So those are the basic get messages. That's kind of all you need to get SNMP up and running. Like in our labs, that's all we're going to do because we're not supposed to deep dive into SNMP according to the CCNA exam objectives. But then we also have set messages. So this is when you configure your NMS server and your agent to allow writable information to be sent via SNMP. So this set message is when you give write access from the NMS to your agents. And also, this is kind of on the assumption that you're allowing this to happen via the software. So maybe some SNMP softwares don't allow you to do configuration. SolarWinds definitely does. And you can do that with an SNMP set message. So as you can see here, it's pretty much saying for OID, whatever this is, we're assuming it's an interface. You want to set information on that OID, okay? So pretty simple SNMP set message. And then we have traps. So we're going to go over traps and informs. So they do the same thing, but one's reliable and one's not. So an SNMP trap message is not reliable. Something I definitely want you to write down in your notes. So an SNMP trap message is used when you, the administrator, want to set a trigger on an SNMP agent to send to your NMS server. And then when we do that, if this NMS server is configured to send us alerts via like email or SMS, we can get that faster than maybe the NMS only doing polls for something every 30 minutes. Because remember, NMS server is polling, and we got to set those poll thresholds as well. So if for some reason this interface goes down, and we're only polling for the up and down status of an interface every 60 seconds, and maybe this is just like a software limitation on our NMS, maybe we want to learn about that sooner. So what we can do on this agent is set up an SNMP trap message to be sent if interface gig 01 goes down. Okay? So that's what a trap message is. and you set this. Trap messages are set by you, the administrator. It's an SNMP message or protocol data unit. I probably got this definition off Google. And essentially, it's sending what's called an unrequested message to the manager. Because remember, in SNMP architecture, it's the NMS that should be polling the agent. But we have pretty much said, hey, we don't want to just rely on the poll intervals for the NMS. We want our actual agent to send a trap message if something goes hard down or anything we configure that we want to be sent. Now, why is it not reliable? Because there's no way for the agent to verify or confirm that the NMS got that message. So essentially, yeah, if this interface went down, that trap isn't ever going to make it, and this agent will never be able to log that information. Now with SNMP informs, you're doing the exact same thing, except it's reliable because you're getting acknowledgement back from the NMS that you got that trap message. So now that agent can put that maybe in its syslog, so that when you're doing maybe root cause analysis, you want to go through logs, you can see that, okay, there was communication via my redundant link when my primary link gig 00 went down, gig 01 did take over because that NMS server was able to get this SNMP inform message saying, hey, this went down. So they do the same thing, except an inform message is reliable. All right, so we're going to go ahead and pause here before we go over the SNMP versions. And then when we come back, we'll go over the versions, the configurations, and then the security levels on SNMP, because that definitely matters when we go over the differences between the versions. So thank you for viewing and stay tuned for lesson 2.